We're going to be finding the volume found by taking the region defined by y equals square root of x, y equals 0, and x equals 3, and then rotating that about the x-axis. So in order to visualize this and determine which method we need to use, we're going to need a fairly good picture. Okay. So I'm going to start with y equals square root of x. Okay. Y equals 0, of course, is the x-axis, and here is my line x equals 3. So this is my original region that I'm going to take. Okay. Now, when I rotate it about the x-axis, it literally turns into looking like this a little bit. Okay. All right, now, there are several methods to find volume. The easiest is disk method, which we're going to be able to use here. And I can know I'm going to be able to use disk method by looking at what happens when I slice it into pieces perpendicular to the axis of rotation. So this was my axis of rotation. I'm going to take a slice this way with a little bit of thickness all the way down. Okay. Now if you were to look at this slice, it looks like a disc. Okay. With a little bit of a radius and a little bit of what we call height. Okay. Now, this disc is essentially a cylindrical shape, and that is the formula we're going to use to approximate the volume of a slice of our volume. So, volume of a cylinder is pi r squared times its height, which in our case, the radius is found right here, always going through the original region. And if you look at that, that just happens to be the y-coordinate of this point of the graph. So radius is just the y-coordinate. Now h is the little tiny thickness, and since I sliced it this way, my thickness is a little tiny change in x, which we call delta x. Now, we don't like both y's and x's in our formula, and since we have a delta x, everything else needs to be in terms of x. So I'm going to replace the y with what y is equal to, which is square root of x. Okay, and then clean this up a little bit. This is then the volume of a single one of my little thin slices. Okay. Now, if you add them all up and then take a limit so that we're no longer approximating, that finds the actual volume and it turns it into an integral because the limit of a sum is an integral. Okay. We're going to be integrating pi x dx because the delta x turns into dx when you put a limit in front of it. Now, we need our limits of integration. So I look at this and I'm taking all my slices in this manner from the leftmost point of the graph to the rightmost point of my region. This was x equals 0 to x equals 3. Okay. Now I find an antiderivative. This is pi over 2x squared evaluated from 0 to 3, which is pi over 2 times 9 minus pi over 2 times 0, otherwise known as 9 pi over 2. For the volume of my solid.